Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA Coaching Center, Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing free content in our YouTube channel that is for AE-AEE civil branch students. AE-AEE కి ఎవరైతే ప్రిపేర్ అవుతున్నారో సివిల్ బ్రాంచ్ స్టూడెంట్స్ కి వాళ్ళ కొరకు from today onwards guys we are going to be updating every day in detail video lecture for the AE-AEE aspirants. My dear students, this is the video 1. every day ఒక కొత్త వీడియోతో అప్డేట్ అవుతూనే ఉంటుంది ఈ వీడియోలో. ఓకేనా, we are going to be starting the subject fluid mechanics, first chapter properties of fluid. In this very video we are going to be discussing about what is solid, what is fluid, what are the differences of solids and fluid, what is the introduction part for the solid mechanics, fluid mechanics, engineering mechanics, ideal fluid, rigid fluid and their deformation when you apply some shear force over it, how they are going to respond. So regarding these topics we are going to be discussing in this very video lecture. Why is this entire video lecture guys? At the end of the video I'll be having a good news for you, that is for all AE-AEE aspirants. Okay, I wish you all the best. Entire video ni watch cheyani, and my dear students, those who have not subscribed so far, subscribe the channel, press the bell icon to be notified for every updates from the SAIMEDHA Hyderabad, because every day we are going to be updating a video lecture for free content, promotional content in our YouTube channel. So stay tuned, let's start the video now. In this video lectures we are going to talk about in detail explanation of the chapter fluid mechanics, hydraulic and hydraulic machines. Before entering into the fluid mechanics, actually all these sciences, fluid mechanics, solid mechanics, strength of materials, pneumatics, all comes under a science that called as mechanics. Okay, so mechanics is the basic science that we need to understand first. Here in the mechanics, it is a science which deals with the behavior of bodies, which deals with the behavior of bodies under rest or motion, okay. Whereas the science which deals with the behavior of bodies under rest, these are called as statics. The science which deals with the behavior of bodies under motion is called as dynamics. Okay, statics, dynamics. In turn, dynamics can be classified as the science which deals with the behavior of bodies under motion under the influence of force or without consideration of force. Okay, let's say without consideration of force first, without consideration of forces or masses causing the motion, without consideration of influence of forces, and the second one will be with consideration of influence of forces. Okay, then whenever we talk about this without, this science name is kinematics, and we discussed about with, it is called as usually kinetics. Okay, with consideration of forces and without consideration of forces. So actually when we talk about the bodies can be classified into two types. Bodies are classified into two types, and based on the rigid bodies. What is the meaning of rigid? Rigid means, in one line if you want to write the answer, rigid bodies are non-deformable bodies. Rigid bodies are non-deformable bodies, where deformation is going to become what? Zero. What is the meaning of deformation, sir? Deformation means change in the dimensions, length, breadth, height, thickness, width. Any dimension is not going to change by an inch or mm or micron also when the load is getting applied. Okay, perfect solid body, non-deformable bodies, deformation equal to 0, or you can write as change in dimension equals to 0. Change in dimension is equals to 0. We know the formula for strain, where strain is called as change in dimension by original dimension. Change in the dimension with respect to original dimension. Original dimensions. Okay, that value is also going to become what? 0. Go through it. Bodies are of two types, rigid bodies and deformable bodies. Rigid bodies and deformable bodies. In the deformable bodies, the real bodies, let's say real, can be classified into two types, that are solid and fluid. Again, deformable, solid here. Okay. So the science which deals with the behavior of only rigid bodies, where we are not going to talk about any sort of deformation, this science is engineering mechanics. Okay. So engineering mechanics always talks about which bodies? Engineering mechanics always talks about rigid bodies. Okay. Go through it. The science which deals with the behavior of rigid bodies comes under what? Comes under the engineering mechanics. Whereas the science which deals with the behavior of only solid, that too real solid, where we are going to discuss about deformation, stresses, strain, what is the strength, what is the factor of safety. Okay, that science called as strength of materials. What is it called as? Strength of materials. The science which deals with the behavior of fluid, real fluid, usually real and as well as ideal fluids also will be seeking in this science, and this science is called as fluid mechanics. This is what we need to talk about. Okay, go through it. So there are how many sciences that we need to talk about now? There are 3 sciences. One is engineering mechanics, the science which deals with the behavior of only rigid bodies. The science which deals with the behavior of only solid, and that to real solid, is strength of materials. It can also be regarded as solid mechanics. Solid, it can also be regarded as solid mechanics. Okay, solid mechanics. And the last one is the science which deals with the behavior of fluid. It can be regarded as fluid mechanics. Okay, go through it. Try to create the patterns in your mind, because once and for all, once you learn this subject, okay, your intention must be, I am not going to study the subject one more time, I am going to revise only. This subject is going to be having an importance in state public service commission examinations, in GATE examination and engineering services examination too. Okay, so let's gonna revise. Let's revise one more time. What is the mechanics? Mechanics is a science which deals with the behavior of bodies. It can be in the state of rest, or it can be there in the state of motion. The science which deals with the behavior of bodies under the rest condition is called as statics. Motion is called as dynamics, with consideration of force kinetics, without consideration of force kinematics. So if we discuss about the bodies concept, bodies are classified into two types: rigid bodies and resistant bodies, deformable bodies. What is the meaning of rigid? Rigid is non-deformable body, deformation equal to 0, change in dimension equal to 0, strain is equals to 0. If you want to plot a stress versus strain diagram, okay, observe here, if you are going to plot a stress versus strain diagram for a rigid body, question will be appearing like this. What do we have here? Stress, and then you have here strain, stress versus strain, and the asked question is to plot the stress versus strain diagram. So stress is going on increasing, but there is no strain, there is no deformation. Okay, stress is increasing, no deformation, because rigid bodies does not have any sort of deformation. No deformation means what? No strain. So what is the strain value going to become? Strain value is equals to 0. Strain is 0, stress is going on increasing. That means this perfect body, perfect solid body, rigid bodies are going to be represented with which axis? Y axis. Okay, go through it once. What is the question can be appear here? rigid bodies are represented by dash when plotted on a stress strain curve. When plotted on a stress strain curve, what is the answer going to become? The answer is going to become as y-axis. Y-axis. Similarly, there is one more question that we need to memorize, that is ideal fluid. Okay, rigid body means ideal solid. Ideal solid, perfect solid. For the perfect solid we have the y-axis. Then ideal fluid is represented by dash when plotted on shear stress versus rate of shear strain diagram. What is shear stress? What is shear strain? How it is going to influencing the fluid? Okay, we are going to see later. But for now, as comparative question is there for the ideal solid, for the ideal fluid, here we need to memorize the answer as what? X-axis. Okay. Let me plot the diagram for you so that you can remember this one. Here we have shear stress and here we have rate of shear strain. Then under this condition, under no stress condition, we are not applying any stress, but still the deformation is going to be continued for which fluid? Ideal fluid. So ideal fluids are represented on a shear stress versus rate of shear strain diagram by which axis will be your question, and the answer is going to become what? X-axis. Remember that ideal fluid is represented by x-axis, ideal solid is represented by y-axis over the stress versus strain diagrams. Okay, let's go back and revise. Here we discussed about the mechanics, statics, kinematics, kinetics. Then we discussed about strength of material, solid mechanics, fluid mechanics, and then we discussed about how a rigid body and how a ideal fluid is going to look like over the shear stress versus shear strain diagram. Okay, let's move on a little bit. First of all, pause the video and note it down up to here. Okay, for that you can change the slide. Complete it for this one, go for this one also. Try to remember this point regarding the rigid body and as well as the ideal fluid body. Whereas rigid body, perfect solid bodies are represented with y-axis over the stress versus strain diagram. Shear stress versus rate of shear strain, we are having the ideal fluid represented by X diagram. Okay, so now we know about the bodies. Let me tell you that inside the fluid also they are of two types. Fluid can be classified into incompressible and compressible fluid, where incompressible fluids are liquid, compressible fluids are called as gases. So if you want to write the classification of the fluid, here we can write in simple words. In detail, when the compressibility definition and property comes, we will discuss there also. Okay. For the fluids now classified as two types. What are they? Incompressible fluids, incompressible fluids, and compressible fluids. Incompressible fluids, compressible fluids. Incompressible, the meaning of incompressible is density constant. Density is a constant. Here density is a variable. Density changes. Okay. What happens when you differentiate a constant? Differentiation of constant is going to become 0. Differentiation of a variable is a non-zero term. Okay. What is the meaning of density here? Molecule spacing, closeness between the molecules is remaining what? Same. Okay. Here you can say the molecule closeness is changing when the application of pressure is there. The distance between the molecule is what? Changing. Here the distance is remaining what? Constant. Initial and final density between molecule density is remaining always what? Constant. Okay, that is the meaning here regarding the incompressible and compressible. This density is constant. What is the example, sir? Here density is constant. Example is what? Liquids. That too ideal liquids. Ideal liquids are incompressible. Whereas here you can say as gases. Gases are compressible fluids. The science which deals with the behavior of only liquids. The science which deals with the behavior of only liquids. When we talk about liquids, this science is called as hydraulics. What is the name of the science here? Hydraulics. And the science which deals with the behavior of gases, this science name is pneumatics. What is it called as, guys? Pneumatics. Go through it once. Try to memorize the names here. The science which deals with the behavior of liquids is called as hydraulics, and the science which deals with the behavior of gases is called as pneumatics. Pneuma means air. Pneuma means water, air. Whereas hydro means water. So from water we can say it is related to liquids, air we can say it is related to gases. Okay. So now we know about the sciences. That is, first one is engineering mechanics. Then we discussed about fluid mechanics, and then we discussed about solid mechanics. Solid mechanics can also be regarded as strength of materials. And then we have for liquids, that is hydraulics. And then we have for the gases, that is pneumatics. Okay. Pneumatics is there for air, gases science. Hydraulics is there for only liquids. Strength of material is there for solids. Fluid mechanics is there for fluids. Engineering mechanics is there for which bodies? Rigid bodies. Okay. Likewise, we can memorize here in a table form. Okay, go through it once. Chalo, pause the video and note it down so that we can go for the next slide. Okay, go through it once, and then we'll see the differences in between the solid and fluid. Okay, let's see. So, what is the difference between solid and fluids? Differences between solid and fluids. If you can say here, let's classify first one as solid and second one as fluid. Solid will be having a definite pattern, definite shape and volume, but fluid does not have. For our study, when we talk about fluids, you need to memorize that this fluid is likewise liquid. Okay, we're not going to discuss about the gases in the hydraulics and fluid mechanics concept. We'll be discussing only about the liquid. So wherever we see the fluid, now you have to assume that we are talking about only liquids rather than gases. Okay, so solid, if you see, this is a matter, a cube. Let's say this is A, B, C, D. When you apply some tangential force over it, tangential which touches the only surface, tangential force, or in short we can see as a shear force, then what is going to be happening? It is going to shift its position, sir. Suppose bottom is fixed here, and then what is going to be happening? This body is going to shift its position, right? Observe like this. The body is shifting its position. That means B has been shifted to what now? B dash. Let's say this is A, creating a strain. Let's say this is 5. This is called as shear strain. If you take out this diagram, you can understand it much better. Observe, this is the diagram here. What do we have? 5. What is this value? B. What is this value? B dash. What is this value? A. So then what is the formula for tan phi? What is the formula for this angle? Shear strain, tan phi, tan being very small, tan 0 0, so it can be neglected and we can write phi. Phi is equals to opposite by adjacent. What is the opposite here? B, B dash. What is the adjacent here? AB. So what is the formula gonna become? Opposite by adjacent, VB dash by AB. So this is the formula for the shear strain. This is the formula for shear strain. What we can write here? Shear strain formula is VB dash divided by AB. What we apply? Tangential force, that is shear stress upon a particular area. So shear stress and shear strain are directly proportional to each other. So what is the formula? Shear stress is directly proportional to shear strain. Shear stress is directly proportional to shear strain. This happens with a solid. Okay, go through it once. What do we have here? A solid body, to which what are we applying? A tangential force. When we apply a tangential force over a solid body, then what is going to be happening? It is going to shift its position. It is going to be having some angular deformation. This angular deformation is taken out by means of a tan slope formula. Tan phi equal to opposite by adjacent. How much is the in the linear dimension change in the dimension, the linear direction change in dimension is there? BB dash. Perpendicular to it, AB. Opposite by adjacent, BB dash by AB. So what is the angular deformation now? Opposite by adjacent, that is BB dash divided by AB. That happens with what? Solids. Now let's see inside the fluid. Inside a fluid, suppose this is water, some fluid is there. Okay, and now I am applying again which force? Tangential force to it. Then it is going to be creating some angular deformation again. Yes or no? Let's say that angular deformation is equals to, let's say this is dx in the direction of dy, creating an angular deformation, let's say it is d5. Okay, creating an angular deformation, let's say it is d5. So the particle, when it is going to be moving from its position, guys, it will be having some velocity, displacement, rate of change of displacement with respect to time. So if you write here d5, that is dynamic action, we can say here dynamics and continuous deformation. Dynamic and continuous deformation. Whereas here in this case we will be having which deformation? Static deformation. There is no motion. Okay, this is static deformation, and here we have dynamic and continuous deformation. Where static is there, here velocity is going to become 0. Rate of change of displacement with respect to time is 0. But here rate of change of displacement equals some velocity. Velocity will be there with which the particle, the fluid droplet, the molecule is going to be moving in the forward direction. So here continuous deformation is there. So here what we can write as an important point is this nature is called as, resistance is called as viscous nature. What is it called as? Viscous nature. Whereas here we will be having a nature called as elastic nature. Elastic nature. Here elasticity is the property which is going to be creating the resistance, and here viscosity is the property which is going to be creating the resistance. So now you can compare and see how the differences is there in between a solid deformation to that of the fluid deformation. The next point is, if you see this dx by dy, okay, what is the formula for shear strain? That is opposite divided by adjacent. Opposite divided by adjacent, dx divided by dy. Here we will have rate of change of, that is with respect to time, because dynamic it is. So we will be writing here dx divided by dt into 1 divided by dy. That is equals to dx by dt is rate of change of displacement, that is velocity. So this is dv divided by dy. So here we have to memorize that this value is called as rate of shear strain. What is it called as? Rate of shear strain. That means shear stress is directly proportional to shear strain, and here shear stress is directly proportional to rate of shear strain. Time parameter is added. That too it is equals to dv by dy, and dv by dy is called as velocity gradient. Velocity gradient. Okay, go through it. So now we know the three differences. What are the three differences? Static deformation, continuous dynamic deformation. Elastic nature is responsible for the resistance over the tangential force or shear force. Here we will be having the viscosity effect coming into existence, which is going to create the resistance. Here we can say that shear stress is directly proportional to shear strain. That is the third point we can see here. And here in this case we can say that what we apply shear stress, and that is directly proportional to rate of shear strain. So third point I am going to write it here. It is shear stress is directly proportional to rate of shear strain. Okay, 3 points. Focus over the board. Try to memorize. Let me write it on a separate board so that we can understand it better. So in the solids section, we'll be memorizing the first important point as they will be having which nature? Elastic nature. Okay, Young's modulus of elasticity you can say. Here we'll be having what? Viscous nature. That is rigidity modulus, shear stress, shear strain, rigidity modulus here will come into existence. The deformation in solids is which deformation? Static deformation. Whereas in case of fluids, we have which sort of deformation? We are having continuous deformation. We are going to be having what? Continuous deformation. This continuous deformation is dynamic deformation. Dynamic deformation. On the third point, third note, we can write it here that shear stress is directly proportional to shear strain. Whereas here, we will be writing that shear stress is directly proportional to rate of shear strain. And that too, it is equals to velocity gradient. Remember this formula because this formula is going to be useful when we are going to talk about Newton's law of viscosity. Okay, go through it once. So now we know about what is the mechanics, what is solid mechanics, what is fluid mechanics, hydraulics, pneumatics. In turn, then we discussed about rigid bodies, non-deformable bodies, deformation 0, strain 0, stress strain diagram for the rigid bodies, ideal bodies, and stress strain diagram for ideal fluid. Then we discussed about what is the basic differences in between the solid and a fluid under the application of some tangential force. Okay, go through it once. I'll go with the previous slide so that you can copy it down. Okay, pause the video and note it down. So congratulations guys, you have made it so far. ఈ వీడియోని వాచ్ చేశారు డెఫినెట్లీ. ఈ వీడియో మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి. సార్ వాట్ ఈస్ దట్ ఎక్సైటింగ్ న్యూస్ that you were talking about? SAIMEDHA Hyderabad is starting new batches for AE and AEE aspirants. My dear students, batch 1 కి notifications, batch 1 కి admissions అనేది ఆల్రెడీ జరిగిపోయినాయి. batch 2 కొరకు ఈ ప్రమోషనల్ కంటెంట్ అనేది చేయడం జరుగుతుంది. Sir, my dear students, we are conducting a talent test examination for those who are interested in AE, AEE. ఖచ్చితంగా మన స్క్రోలింగ్ లో ఉన్న మొబైల్ numbers ki contact cheyandi. Based on talent test, you will be getting the maximum concessions, 1 year paatuga coaching, free material, free test series, free online coaching, free offline coaching, regarding every detail guys. Whatever you are having a little bit of interest and you want to join in the SAIMEDHA Hyderabad, ఖచ్చితంగా ఈ వీడియోని షేర్ చేయండి మీ సివిల్ ఫ్రెండ్స్ తో, మీ సివిల్ ఫ్యాకల్టీస్ తో, ప్రతి ఒక్కరితో ఈ వీడియోని ఖచ్చితంగా షేర్ చేయండి. అండ్ డోంట్ ఫర్గెట్ టు సబ్స్క్రైబ్ ద ఛానల్. ఏ డీటెయిల్ కావాలన్నా సరే స్కోరింగ్ లో ఉన్న మొబైల్ నంబర్ కి జస్ట్ టేక్ ద కాల్ అండ్ గెట్ ది ఫుల్ ఇన్ఫర్మేషన్. థ్యాంక్ యూ వెరీ మచ్ గైస్. అండ్ ఇంకా డిస్క్రిప్షన్ లో టెలిగ్రామ్ ఛానల్ గా లింక్ అనేది పెడతాను. ఖచ్చితంగా ఆ టెలిగ్రామ్ ఛానల్ ని జాయిన్ అవ్వండి అండ్ డౌన్లోడ్ ది యాప్ Space Gate. Thank you very much guys. With one more video, I'll come back tomorrow evening again. Thank you very much. Subscribe the channel.